Hello everyone, I'm Kunal, going to present my idea on building intelligent BMS for EVs. So, what's the problem now? Every day we come across lot of news that electric car caught fire in India, led to the loss of life and property. So, what is actually responsible for this? It is the battery management system used in the battery pack of EVs. Now, let's understand what BMS is. Every EVs contain battery packs, and each battery pack is made up of a small cell. Just to use collectively all these small cell efficiently, BMS is used. Now let's understand what is responsible for the fire. Suppose a battery pack is made up of four cells, and BMS estimates the SOC of the each cell and finds that second one has the more charge than other. So it starts drawing more power from that cell to balance it. So what if the sensing is wrong? It will drain unnecessary more power from the cell only, thus making the pack more unstable. Due to the excess power draining from one cell, overheating happens and eventually it catches fire. Currently, the cell modeling is the most popular method for estimating SOC. So why it is estimated wrong here, wrong there? It's because most of the BMS models on the lower temperature, which are not suitable on Indian roads, as the temperature is much higher compared to Europe and China, where all these BMS are manufactured. So, in our method, we decided to train a deep learning model on our novel data on Indian context. We will use voltage, current, and the temperature to estimate SOC. Deep learning estimate eliminates the problem of complex modeling, and if enough data acquired, a very accurate prediction can be made. Yeah. We will acquire data by simulating the power profile of EVs in the cell. Let's understand the simulation. When we start an EV from rest, its velocity increases. Thus, the power profile is basically the voltage and the current reading of the EVs at a particular interval on the traffic of Indian roads. This data is easily available on the open source. So here, a battery cycle discharges a cell according to that power profile, thus simulating the EVs for that cell. And we collect data using various sensors stored in instrumentation. We will be using RTD, Hall effect sensor, and voltage sensor here. As RTD is more accurate with linear output and long lasting in nature, we are preferring it over thermocouple and thermistor. And Hall effect sensor and the voltage sensor is much lighter and cheaper than ammeter and voltmeter, just using this in experiment. Now, after collecting data and training the deep learning model, we have to load that model in a microcontroller for the real time estimation of SOC and balancing the algorithm to act as a BMS. We are using STM32 here because by using just library named QBKI, we can easily load our model in the microcontroller and use it in real time with other sensors. That's it. We are ready with our cheap BMS. So this was our idea. Now let's understand what the novelty of our project is. This particular project will be the first model on the Indian context, and very few research papers are published till now, and all the research papers are based out of the temperature which with very low margin. Yeah, and it can also work on the both sodium and lithium ion cell. Yeah. The whole market of the BMS is around $7.8 billion and it increasing at a compound annual growth rate of 18.1%. It's amazing technology with amazing return. Thank you. Let me know if there are any standing question.